Let's simplify some expressions. There's going to be some instructions that we get after a few of those fill in the blanks. Now we got to get on to figuring out how to simplify some stuff. So let's see what we mean by that. So all the instructions, I got 3 problems for you. All 3 are just simplify the following expression. So here's the first one. Cosine of x minus cosine of x times sine squared of x. We want to simplify. Give you an example. What if you had x minus x times y squared? Could you factor that? Could you clean it up? Could you do anything to it? Yeah, of course you could, right? Don't the pictures match right there? The x's and the x's. So you just pull an x out and you're left with 1 minus y squared. Well, that's what's going on here. 2 things in common. You got cosine of x. That word pops up on both of them. So here we go. Factor out the cosine of x to the outside. When we factor, that's division. Cosine of x divided by cosine of x is 1. And then when you divide out your cosine of x over here, come on, what's left over? You're just going to have that sine squared of x. Cool. Cool. This is totally equal. We got it. But wait a second. Uh-oh. I think I remember something. Sine squared plus cosine squared is equal to 1. And if we subtract over the sine squared, I think we can clean stuff up. The cosine squared of x is equal to 1 minus sine squared of x. Oh shit. Let's pop it in right there. So you're going to get the cosine of x times, and instead of writing 1 minus sine squared, you're going to write in cosine squared of x. So here it is, one more step, and we got this thing completely simplified. So if you have cosine times cosine squared, if you had x times x squared, wouldn't it be x cubed? Same idea. So we get cosine cubed of x. That's a simplified down answer. We simplified our expression. Cool. Let's go. So you see how we had to use the fact of like a little bit of algebra, seeing if the pictures match and factor it out. Then we needed to know an identity. It can get tricky. All right. These are fun. Not much to it. You see something like this and it needs to be simplified. There's one game and one game only. There's only sine and cosine. There's only sine and cosine. Don't get overwhelmed. Just look and go, ha. I don't play with you secant. I don't play with you tangent, cosecant. You can suck it. You don't like it. No identity is going to pop out of this also. Like, there's no 1 minus sine squared that's going to come out. No, let's just change everything. Everything that's not a sine squared. So I'm going to leave this sine squared alone, the sine squared of x. And I'm going to leave this cosine of x alone. I'm not touching that. I'm going to leave that alone. But I'm going to change secant. Change secant to 1 over cosine of x. Notice what I'm doing here with the sine squared. Because I have to flip it to its reciprocal, I move that sine squared up. Maybe you even do this. You know what I mean? Like, that's what's going on up top. It's sine squared over 1. Just so you don't screw up the fractions and accidentally put the cosine with the sine squared. Cool. Now let's keep going. I know this is weird if this is your first time doing it. Now we got tangent. Tangent is sine over cosine. So if we just replace this and wrote that. Oh shoot, looks like things might cancel out or something. And then we have our cosecant, which is 1 over sine. Oh, gosh dang it. Let's just look down here. Just look here. Do you notice anything? Do you see anything strange? Just look there. There's 2 different things. When you have a fraction like this, there's like an implied parenthesis. You're supposed to do everything inside of it first. So don't worry about the whole thing. Let's just look here. What's left? Just 1. So what are we left with? We got our 1 over cosine of x times our sine squared of x from up top, and the bottom's 1. So I could. Do you want that there? I don't think so. So I think by putting it together, you get sine squared over cosine of x. Depending upon how you want to write it, I think that's pretty simplified. I like sines and cosines. But you could also write it as sine of x over cosine of x times sine of x. You see that, how I broke the squared into two pieces? Because you can write it over 1. Isn't that how you multiply? Don't you put things back together that way? So by doing that, we could say that sine over cosine becomes tangent of x. We can say the tangent of x, sine of x. Cool. Games that we have to be able to play, like simplifying things down, because soon we're going to be trying to get the left-hand side to match the right-hand side. We got to learn all of our different skills. So there's only sine and cosine is a powerful one. When you're stuck, that's what you go to. Just change everything to sines and cosines and see what happens. And our last one, there will be just a couple subtle tricks through this. All right, now I mentioned the fact it's always good, change your sines and your cosines. When stuff is squared, maybe don't touch it. Like secant squareds and stuff, I don't know, I wouldn't touch it. I think this looks similar to the first problem, where there's a minus sign right here, right? And these two pictures match. They're separated out. Again, so we have a problem just like that first one. So let's factor out that secant squared. Let's take that secant squared and let's bring that out to the front. And then we see what are we left over with. What's going to be there? So there'd be a sine squared of x. And then we'd have a minus 1. That looks close. Doesn't that look like something? That's not what we have, right? Didn't we have it, we had this. Didn't we show before that cosine squared of x is equal to 1 minus sine squared of x? Oh, by the way, it's going to use u when it does all these things. I like using x. You don't want to use u? Write x. Just make sure to pop it back in at the very end. You don't like the picture? Change it. Just change it. If you caught that, you caught it. So we had this. The problem is, dude, we have the opposite. We need the opposite, right? This one has a positive 1. This one has a negative 1. This one has a negative sine squared. This one has a positive sine squared. When it's turned around, you get what I mean, turned around? Like this way. With a subtraction in the center. When it's turned around with a subtraction in the center, it means they're just negatives of each other. It's the same thing. You just got to change the sign. So really, just hit it with a negative on this side. So negative cosine squared will equal negative 1. We're just changing both terms, right? To negative. Just hit it with a negative on both. Change both signs. But now if you just turn this thing around, because addition's commutative, you can just turn it so it's sine squared of x. It goes over here, that positive 1, and then we subtract out the 1. That's a subtly tricky thing, especially at the beginning. So we can go through and replace it right there. So we have secant squared of x equal to secant squared of x times negative cosine squared of x. Cool. Well, there are no more pluses or minuses anywhere. That's telling me there is only sine and cosine. There is only sine and cosine. Let's see what's up here. We take our secant squared, we're going to change it to 1 over cosine squared of x, times what we got up top, that negative cosine squared of x. Don't be afraid to cancel things out. That's the game. The cosine squareds go away. Don't forget the sign. The answer is negative 1. That's a tough one. I ramped it up. A lot of little subtleties in it. But these are our games where we need to get better with it. You got a few homework problems like it, and we're also going to do some factoring ones as well. So next time we come back, we're going to start talking about factoring, just like you learned in an algebra class, except we're going to do it with words. So I will see you then.